Good morning, students. Today's topic is Hadoop distributed file system, that is HDFS. Before entering into this topic, we want to know about what is Hadoop. Hadoop is an open source framework that allows to store and access big data in the distributed environment. The Hadoop has two parts. The first part is computation part. That part is handled with the help of MapReduce. Second part is storage layer, that is handled with HDFS, that is Hadoop distributed file system. That is today's topic. Now we see about overview about this presentation. First we see about DFS. Second we see about what is HDFS. In the last we see about HDFS architecture. First, what is a distributed file system? It's a method to store and access files in the client server environment, and also it holds a large amount of data, clients distributed across a network. The machines are distributed across the network, and also we store the data to all the machines across the network. So another topic is NFS, network file system. It's a straightforward design, remote access, single machine. Then it has some constraints. Next is HDFS, that's a Hadoop distributed file system. In this system we can store terabytes of data and also petabytes of data. Simply we say means here we store large amount of data comparing to NFS, network file system, and it's a very reliable and also fast and scalable access. Then integrate well with MapReduce. So that is a computation layer in the Hadoop environment, and also it has some restrictions for handling the applications. Restricts the data to handle by the applications. Next is Hadoop distributed file system versus NFS. In this slide shows the differences between these two. Here everything is stored in a single machine, but in this HDFS the data is stored in the whole network. That is the major difference between HDFS and NFS. Here single machine makes part of its file system available to other machines, but here single virtual system spread over many machines. Second, sequential or random access is allowed here. Here optimized for sequential read and local access. If advantage means here we have simplicity, genericity, then transparency. Here high throughput, then high capacity. Then as a disadvantage means here storage capacity and throughput limited by single server. Here specialized for particular types of applications. Next slide explain about the basics of HDFS. It's a distributed file system. Then it runs on a commodity hardware and stream data at high bandwidth. Challenge, tolerate node failure without data loss. Here we are using very good tolerant that helps to that avoids the loss of data. That means here we can store the data across the network. If one particular machine or a particular component fail means we can easily access and also we can easily retrieve all the data. And also it's simple concurrency model. Computation is near the data. Then portability, built using Java. We can easily build with the help of Java. So therefore that is the main advantage of Hadoop. Second, interface patterned after Unix file system. File system, metadata and application data stored separately. Metadata is on dedicated server called name node. All the metadata, that is data about data, stored in a name node, and all the application data, that is stored in the data nodes. So here we have two separate nodes. One is name node and another one is data node. The name node contains all the that's data about data. The file is stored where, what are the names, we can store the files. In that way it contains all the information, but this data node contains the actual data. And HDFS is a good for very large files, streaming data access, then commodity hardware. So we don't have any latest configuration machine. Here we can easily implement with the help of this commodity hardware concept. That's the main advantage of using HDFS. Then it is not good for low latency data access, lots of small files. If you have only a small file, small amount of data, so in that situation it is not suitable. Second, multiple writers, arbitrary file and modifications. In these situations it is not suitable. Then differences from GFS, that is Google file system, only single writer per file, then open source. It's a purely open source, and also only one writer file is there. So here GFS, NFS, HDFS, all are comes under the distributed system concept. So these GFS, NFS and HDFS have only small amount of difference one between another. It's a HDFS architecture. In this architecture mainly contains namespace, blocks, and then name nodes and data nodes, and then secondary name node. In the namespace, that's a hierarchy of files and directories are stored in RAM, represented on name nodes by inodes. Attributes, permissions, modifications and access times, namespace and disk space are there. Next, blocks. In HDFS, the block is limited up to 128 MB or 64 MB. Large blocks minimize the cost of seeks. Benefits can take advantage of any disk in the cluster, and also it simplifies the storage subsystem. Amount of metadata storage per file is reduced. Fit well with replication. Why here we using maximum amount of storage in a single block means we can reduce the metadata. In that reason we go for a huge size of blocks like this 128 MB and 64 MB. Next is the name nodes and data nodes. Master worker pattern, single name node, master server. Number of data nodes, usually one per node in the cluster. Name node, that is a master, manages file system in the namespace, maintains file system tree and metadata persistently on two files, namespace, image and edit log. Stores locations of blocks but not persistently. Metadata, that is inode data and the list of blocks of each file. The metadata contains details about each and every block and file. That file or that block is stored where, in which computer, in the which network. In that way it contains all the data, all the information. Then data nodes. It's a very important comparing to the name nodes. This data nodes only contains the original data, that is workhorse of the file system. Store and retrieve blocks, send block reports to name node. Do not use data protection mechanisms like RAID, then use replications. So here the original data is stored in this data nodes. So whenever we need, we can easily retrieve with the help of name nodes. Two files, one for data, other for blocks, metadata, including checksums and generation stamp. Size of data file equals actual length of block. Data nodes, start of handshake, that's a namespace ID and software version. With the help of these two information, we can easily identify the data nodes. After handshake, we can easily register. We do the registration process, then storage ID, then block report, then heartbeats. It's a diagram shows the HDFS architecture. We already see about this name node, data nodes, replications, then metadata. Okay, here the name node is there. In this name node contains metadata, that is name and then replicas about this name node, and then these are all the data nodes. So the actual data is stored like this. It's a rack 1 is available in one particular machine. It is available in one particular place or a machine. Here we have some blocks. Here we have some blocks. So whenever the client read those these data from this particular rack. Whenever this particular client means the data is read from this rack 2. So it's a simple architecture about HDFS. Next one is a secondary name node. If name node fails, the file system cannot be used. Once the name node is not available or that name node is failed to retrieve the data, means we can't access all the data that is stored in the distributed environment, that is client server environment. So in this purpose, we are using this secondary name node. Two ways to make it resilient to failure: backup of files, then secondary nodes. We have some backup files, we can use it. Otherwise, with the help of the secondary name node, we can easily retrieve it. Secondary name nodes. It's a periodically merge namespace image with edit lock. Runs on separate physical machine. Has a copy of metadata which can be used to reconstruct state of the name node. It also has some disadvantages. There's a state locks that of the primary name node. Renamed as a checkpoint node. Then periodic and is not continuous. If the name node dies, it does not take over the responsibility of the name node. If that name node is in the live state, we can easily retrieve the secondary name node also possible. If that name node is not available, we can't retrieve the secondary name node also not possible. Okay, in this presentation we see about what is a HDFS and how it is differ from NFS and GFS, and also we see about the Hadoop file system architecture. Okay, thank you.